Hello everyone, thank you for watching this video about ethical AI on AWS. While artificial intelligence has become more and more important nowadays, ethical AI, which talks about dealing with the morals or the principle of morality when using AI to address business problems, is also become a very interesting topic. In this session, I wanted to look deeper into how AWS consider ethical AI on its services. Before diving into the details, here is a brief introduction about myself. I have more than 20 years experience in IT, focusing on digital, data analytics, and emerging tech. I have been involved in various industries such as financial services, healthcare, and technology. I am an enthusiastic promoter of cloud technologies. I am certified on AWS Solution Architect Professional, AWS DevOps Engineer Professional, and AWS Specialty of Database, Data Analytics, Machine Learning, Security, and Advanced Network, as well as Microsoft Azure Solution Architect Expert, Azure DevOps Expert, and Azure Security Engineer. I have also been admitted as one of the AWS Partner Network Ambassador since 2021. You are very welcome to connect me on LinkedIn by scanning the QR code on the bottom right corner. The past decades has witnessed the blooming development of artificial intelligence, AI. Our daily life is full of applications of AI, such as language translation, self-driving vehicles, and face recognition. The beneficial impact of AI systems on the government translates into improving healthcare systems, education, and transportation in smart cities. Other applications that benefit from the implementation of AI systems in the public sector include food supply chain, energy, and environmental management. Ethical AI plays an important role in the field of artificial intelligence. Ethical AI strives to create AI initiatives within the organization or entity that maintain human dignity and do not cause harm to people. It is sometimes divided into a concern with the moral behavior of humans as they design, make, use, and treat artificially intelligent systems, and a concern with the behavior of machines in machine ethics. AI tools typically rely on large volume of various types of data to develop insights. Poorly designed projects built on data that is faulty, inadequate, or biased can have unintended, potentially harmful consequences, like unemployment, inequality, privacy violation, and racism. Moreover, when AI is used in sectors such as medicine, law enforcement, recruiting, data privacy, military defense, or self-driving vehicles, the AI must produce transparent and understandable results that reflect the ethical standards and the norms of our society. High-level expert group on AI, also known as HLEG-AI, is set up by the European Commission and consists of 52 experts on artificial intelligence, including representatives from academia, civil society, as well as industry. The group's general objective is to support the implementation of European strategy on artificial intelligence. This will include the elaboration of recommendations on future-related policy development and on ethical, legal, and societal issues related to AI, including socio-economics challenges. On April 8, 2019, the HLEG-AI published its ethical guidelines for trustworthy artificial intelligence. The guidelines aimed to provide a framework for achieving trustworthy AI. The guidelines put forward a set of 7 requirements that AI systems should meet in order to be deemed trustworthy, and we cite these 7 requirements as the leading principle for ethical AI. Human agency and oversight. AI systems should empower humans, enable them to make wise decisions, and promote their basic rights. Technical robustness and safety. AI systems need to ensure safety, ensure that backup plans are made when problems arise, and that they are accurate, reliable, and repeatable. Privacy and data governance. AI systems should provide the quality and integrity of the data and ensure legitimized access to data. Transparency. The data, system, and AI business model should be transparent. Diversity, non-discrimination, and fairness. Unfair bias could result in potential harmful consequences, so it should be avoided. Societal and environmental well-being. AI systems should consider the environment, including other organisms, and their social impact should be carefully considered. Accountability. Mechanisms in AI systems should be established to ensure accountability for artificial intelligence systems and their results. Now let's focus on our main topic, ethical AI on AWS. As we all know, AWS provides data scientists over 200 full-featured services from data centers globally, including machine learning, cloud computing, data visualization, and so on. Among these diverse services, we found that some of them give great support to the achievement of most territories within ethical AI. The first principle is privacy and data governance. AI systems should ensure the quality and the integrity of the data used, its access protocols, and the capability to process data in a manner that protects privacy. Next is transparency. AI systems should ensure transparency by including 3 elements: traceability, explainability, and open communication about the limitations. Transparency is a key mechanism to realize all other 6 requirements. The last leading principle is diversity, non-discrimination, and fairness. Unfair bias must be avoided, as it could have multiple negative implications. Fostering diversity, AI systems should be accessible to all, regardless of any disability, and involve relevant stakeholders throughout their entire life cycle. Next, I would like to move on to the details about privacy and data governance. Amazon Macy is a fully managed data security and data privacy service that uses machine learning and pattern matching to discover and protect your sensitive data in AWS. It automates the discovery of sensitive data at scale and lowers the cost of protecting your data. The workflow of Amazon Macy could be divided into the following 4 steps. First, we need to enable Amazon Macy through the AWS Management Console or API call. Second, Macy continually evaluates your S3 environment, including bucket-level security and access controls. To be more specific, it automatically provides an inventory of AWS S3 buckets, including a list of unencrypted buckets, publicly accessible buckets, and buckets shared with AWS accounts outside those already defined in AWS organizations. And then, Macy applies machine learning and pattern matching techniques to the buckets you select to identify and alert you to sensitive data, including personal identifiable information, PII, such as names, addresses, and credit card numbers. One point I'd like to emphasize here is that Macy also allows us to define our own custom sensitive data types so we can discover and protect the sensitive data that may be unique to our business or use case. After discovering sensitive data, Macy generates findings and sends them to Amazon CloudWatch events for integration into workflows. Additionally, Macy can be used in combination with AWS services, such as AWS step functions to take automatic remediation actions. AWS De-Identified Data Lake (DIDL) is another tool to support the achievement of data privacy and data governance. A de-identified data lake is an architectural approach designed to help organizations use data as a competitive differentiator while reducing the risk associated with managing all their data, particularly personally identifiable information. DIDL detaches valuable data about habits, behavior, region, and non-identifiable preferences from the actual identity of a person. In other words, the data is no longer associated with a person. A DIDL helps solve the data privacy problem by de-identifying and protecting sensitive information before it even enters your data lake. The process of de-identified data lake can be broken down into 5 steps. The first step is data discovery and cataloging. The data cataloging process enables recording all the places where a person's data is created, captured, and stored. Next, data de-identification plays an important role in the process of de-identified data lake. It includes tokenization, hashing, and slicing of the sensitive data or PII. Tokenization is the specific transformation process, which means that the records still exist, but names and other PII are replaced by a token. The goal is to ensure that businesses have access to the behavior or transactions that belong to a person, but do not know who the person is. And then, thanks to the data de-identification step, the PII is not unavailable. The data matching step allows the exchange of de-identified PII between different parties, which helps build confidence and trust in the process. The following step is data stewardship and classification. The data in the DIDL must be cared for before, during, and after de-identification, and this requires human intervention. Therefore, this step allows the data steward authorized people to classify data into levels and define whether the use is permitted legally or ethically. A common classification model has 4 levels: public, internal, confidential, and restricted. Last but not least, the DIDL analytics process helps organizations get value from data while still complying with data privacy regulations. Now let's talk about transparency. Transparency is one of the leading principles for ethical AI, and AWS has sufficient modules to support the achievement of transparency. Before I introduce the AWS module, let me make sure that everyone knows about bias. I assume most of the audience have a background in machine learning, so you may confuse the bias I am talking about with the bias you already know. Traditionally, bias refers to module bias, which is caused by an imbalance of data, and we can always use recall to identify the imbalance of data. However, the bias in ethical AI refers to the bias from discrimination and unfairness. The bias comes from prejudice of human beings, which is something we need to solve in ethical AI. Now I have illustrated the difference between the traditional bias and the bias from discrimination. Let's find out what AWS offers us to solve this problem. Let me introduce AWS Clarify here. What is AWS Clarify? And how can AWS Clarify help us to achieve the transparency and find out the bias due to discrimination? AWS Clarify is a module integrated with AWS SageMaker, helping data scientists detect both kinds of bias during training, during prediction, and after model implementation by algorithms. Let's look at the left-hand side of this slide. It is the high level of AWS Clarify architecture. First of all, we have data normally from S3, and the configuration goes into SageMaker. The configuration is the matrix to define the bias, and we will talk about it later. After the SageMaker receives the training task, AWS Clarify will start to work with a different computing cluster by using AWS Elastic MapReduce, which is the mechanism to avoid polluting the original model training job. Using the algorithm inside of AWS Clarify and the configuration, Clarify can detect the bias in the minority groups. Finally, AWS Clarify has 3 different outputs, including sending the alarm by AWS SNS, saving the bias matrices and the feature importance into S3, and visualizing the result in the dashboard by AWS QuickSight. In summary, AWS Clarify can not only detect the bias during the training, but also detect the bias after the model is implemented. AWS Clarify can do many things for data scientists, but how does AWS Clarify define the bias? We will talk about it on the next slide. During the rest of today's presentation, we will go through 2 matrices that AWS Clarify uses to detect the bias. Don't be scared by the equation and the mathematics here. We won't talk too much on the equation, and we will walk through some examples to help you understand everything. Here we introduce a metric called treatment equality. We will call it TE for short in the rest of the presentation. TE is the metric to identify which minority group have been discriminated against. Let's look at an example here. Say we have an interview result prediction algorithm. The results of the prediction are positive and negative. Positive means the candidate passed the interview, and the negative means the candidate failed. For example, we have 2 groups of candidates. One group contains 200 females, and one contains 100 males. The purpose of using TE here is to identify whether this predictor has bias on either females or males. Within the female group, 172 candidates were predicted correctly, but 16 candidates mistakenly predicted as fail, and 12 candidates mistakenly predicted as pass. The accuracy is 0.86 after calculation. Within the male group, 86 candidates were predicted correctly, but 10 mistakenly predicted as fail, and 4 mistakenly predicted as pass. The accuracy of this group is also 0.86. Can we say 2 groups have been treated equally since they have the same accuracy? No. We need to take a look at TE. After the calculation, we have the TE at 0.35. If TE is positive, it means the first group in this equation has been biased. And in this example, it means the female group has been discriminated against in this prediction model. And we as ethical data scientists must fix this issue before producing it in the real world. Hope you are still good. So please hold tight and we will go through another matrix on this slide. Here I'm talking about the matrix called difference in positive proportions in the predicted labels. In short, it is DPPL. Again, the equation is boring and we will go through an example here. Say we have a loan approval prediction classifier here. This is also a binary classifier and it has two results which are positive and negative. Positive means this candidate has been approved to get the loan, and the negative means the candidate has been rejected for the loan. We have two groups here. 60 predicted as positive in 100 seniors group and 25 predicted as positive in the 50 juniors group. DPPL is calculated by subtracting the percentage of positive in two groups. In this example, we get 10% for DPPL, meaning the senior group has more positive labels than the junior group. Further, it means that the senior group is more likely than the junior group to get the loan approval. In summary, I introduced the two matrices. People may feel both matrices say roughly the same thing, but T is used in the scenario for detecting bias, and the DPPL is used for detecting privilege. These are all the reference materials when making this video. Today's video is a little heavy on mathematics and statistics, so a special shout out to those who complete this video. I hope you all can get a better idea about ethical AI as well as the implementation on AWS, and how ethical AI can help us to build a better environment for human beings in the AI era. Thank you so much again, and enjoy learning.